the people who missed class on Friday, here are 4 similar triangles. Examine the given side lengths and then enter the missing values. And then we discussed in class how we determine these values. So taking a look at triangle A to B, A to C, and A to D, we're kind of comparing all these triangles. They're all similar. One, it tells us they're all similar and they look all similar. We know that what's really important when we have similar triangles is that they all stay proportional. So if this is 4 and this is 6, I know that 4 times 1.5 is 6. So I'm going to do the same thing from 2. So 2 times 1.5 is 3. The other thing that I can notice is that in triangle A, I know that 2 is half of 4. And when triangles are going to be similar, they're going to stay proportional. So if this is half of 4, or this is half of this line, I know that this is going to be half of this line. So then the same thing here, I notice this is half of this. So this is going to be half of this. So 2.6 times 2 is 5.2. And that's how I find that answer. So going back, this is just, I notice I wonder, messing with the tools, so we're not going to skip that one for now. So Kayla noticed that similar triangles could be formed using shadows of these figures. Where did she see these triangles? So I'm just going to give it to you right now. I see these triangles using a different color from here to the end of the shadow, all the way up to the head, all the way down, and same here, from the base of the mailbox all the way to the top and down. And then from the base of the lamp post to the top and down. Those are where I see similar triangles. They're all right triangles, and they are similar. So let's move on. So now we're looking for the lamppost height. Just like what we did in the warm-up, we figured out the relationship between 2 legs of, or 2 sides of a triangle. We're going to do the same thing here and relate them to the third one. So I'm actually only going to show the length of the person's shadow and the height of the person, as well as the length of the lamppost shadow. I don't even need anything to do with the mailbox. At this point, I have enough information I could figure out how tall the lamppost is. So I'm going to pay attention to the relationship I see between 75 and 30. I know that 30 times 2 is 60, and I know that 30 times 1/2 is 15. 60 plus 15 is 75. So then 30 times 2.5 is 75. So I'm going to take 72 and times that by 2.5. 72 times 2.5 is going to be, let's see, 72 times 2 is going to be 148. Half of 72 is 36. So 148 plus 36. Did I do that right? Pause. 72 times 2.5 is 180. I'm sorry. I don't know where I did my math wrong. 72 times 2.5 is going to be 180. And I know that that's true because I'm going to let this draw it. Yep, we're correct. Yep, perfect. So I know that's true because the relationship between this side and this side was 2.5. And if these are going to be similar triangles, then the relationship between this side and this side is also going to be 2.5 because they're similar triangles. So I know that that's true. Taking a look here at Alma and Nina's strategies for determining the height of the lamppost. Alma used the relationship just like we have been using with scale factor. So she took the mailbox and she was able to multiply 16 by something to get 72. So these two sides are proportional, which is true. And she says that 40 is proportional to this side, which is also true because they're the same corresponding sides. Nina, instead of going with scale factor to the two from the two triangles, she actually used the relationship within the triangle and the two sides. Since she knows these are similar triangles, she knows that these sides have to be proportional. So she's actually taking 40 and 16 and figuring out the relationship between those two, knowing that that's going to be the same relationship between these two. So 40 is still related to the corresponding side, just like 40 is related to the corresponding side here. It's just in two separate ratios because we're comparing this triangle and this triangle versus this side and this side to this side and this side. So taller objects, now we have some more taller objects. If we know that the height of the lamppost is 15 feet and we know that the shadow of the lamppost is 6 feet, we can figure out the relationship between 15 and 6 to figure out the rest of these. You could also, like we talked about before, is find the scale factor and just multiply the scale factor to all of these. Find the scale factor for the lamppost to the tree and then the lamppost to the minaret. Or, easier and quicker, we can just figure out the relationship between 15 and 6. I know that 6 times 2 is 12, and I know that 6 times 1/2 is 3. 12 plus 3 is 15, so I know that the relationship between these two is going to be 2.5. If I do the same thing to 20 and I multiply the length of the shadow by 2.5, I'm going to get the height of the tree. So 20 times 2.5 is going to be... 40, 50. 20 times 2 is 40, and then 20 times 1/2 is 10. So 40 plus 10 is 50. And then the length of this shadow of the minaret is 56 feet. So I'm going to multiply that by my constant, which was 2.5. So then I multiply 56 by 2.5. I know that 50 times 2 is 100. 6 times 2 is 12. So that is going to be 112. 50 times half is 25. 25 plus 3, because half of 6 is 3. 25 plus 3 is 28. So 112 plus 28 is 112. Gosh, my brain's not working today. 112 plus 28. Is that 140? I think that's 140. Yes. Yeah, perfect. So that's how I found it. So I figured that because the relationship between the actual triangle on the lamppost is going to be 2.5, 6 times 2.5 is 15. That's going to stay the same for all three of those, versus having to find the scale factor from the lamppost to the tree and then the scale factor from the tree to the minaret. I could use the same factor on all three of these. So, similar triangle puzzles. Here are 3 similar triangles. Click a side to reveal its length. Determine the rest of the side lengths using as few additional reveals as you can. I am going to take a look at this before I reveal anything. I'm just going to pay attention that I see 4.5 is going to be half of 9. So, very easily I can find this side if I reveal this side. So I know that this is going to be half of this, so that means that this is going to be 6. I also noticed that between 7.5 and 9 that that's a scale of 1.5, I think. 7.5 times 1.5. Oh, I lied. That's not true. 9. I got to figure out the relationship between these two. Is it easier to do these two? I think it's 2/3. If I multiply 9 times 2/3, nope. We got to figure out the relationship between these two right here. $1.2. I'm going to pause for a moment. So I figured out this part because I paid attention to this one. To find this last one, I would actually just use scale factor, because from 9 to 6 is 1.5. So then I know that 7.5 times 1.5, this times 1.5 is going to be 7.5. So I can divide 7.5 and 1.5 to get 5, and that's going to be the length of this. So for these two, I wish I could draw on this. For these two sides, I figured the relationship between themselves, but I found it easier to figure out that this times this divided by 1.5 is 5. this divided by 1.5 is 6. So I use scale factor to find this third side, but I use the relationship between these two sides to find these two sides. I'm going to do the same thing with this one. I'm going to reveal this bottom one because I know that this is going to be double that. So 1.5 times 2 is 3. And then I have to figure out the scale between this triangle and this triangle, or I can do a little bit of noticing that this is 3 and this is 1.5, this is 6 and this is 3. So I know that this triangle is half of this triangle. So I can just multiply all of these by 1/2 to get all of these. So I know that this is going to be 2.5. So I just found my scale factor, but instead of multiplying it, I divided it by 2. But you can multiply it by 1/2. So I used a strategy of the relationship, I used a strategy of proportional ratios between side lengths to find the first two sides of both triangles. I then found the scale factor to find the third side. And that's what I would say. And then move on. This one was really, really challenging for a lot of people. And because I can't draw on it, I'm actually not going to expect you to do this. Now, if you want to solve it, you absolutely can. It's the same idea, similar triangles, and you have the lengths of 1. You can reveal these. You can find the relationship between 8 and 12. You know that 8 times 1.5 is 12. So whatever this is, you can figure out this length. But then they're not asking for the whole length of this side of the triangle. They're only asking for this part, which is why it makes it really challenging. So if I say, I reveal this and I see that it's 20, I know that from this point all the way down is going to be 1.5 times more than that. So 1.5 times 20 is going to be 30. So this whole section right here, this whole line is 30. But then I also know that I'm not looking for this whole line. I already have 12. So I'm just looking from here to here. So 30 minus 12 is going to be 18. And that's the length from here to here. So that's why it's really confusing, because it's not actually making you put in the entire lengths. It's only making you put in this length. So if from here to here is 1.5, I can figure out from here to here is 1.25. Because 8 times 1 is 8. 8 times 1/4 is 2. So 8 plus 2 is 10. So 1.25. I can multiply this by 1.25. So 20 times 1 is 20. And then 20 times 1/4 is 5. So I know that from here to here it's 25, but I already have 10. So from here to here it's 25 minus 10, which this little length right here is then going to be 15. This whole side of the triangle is 25, but only this section is 15 because we're only looking for that since we already have this part. I'm going to reveal another. And I'm going to reveal this right here. So I again know that this is going to be a relationship of 1.5. So this times from here to here is going to be 30 times 1.5, which is 45. But because I already know that this is 18 and this is 12, I take 45, subtract 12, subtract 18, and the answer is 45 minus 20... 20, 30, so 45 minus 30 is 15, so this is 15 as well. And then like we found out that this is 1.25, the relationship between 8 and 10, so 30 times 1.25, 30 times 1 is 3, and then 30 times 1/4 is 27, 7.5, 30, okay, wait, 30 times 1/4 equals to 30/4. So then 4 goes into 30 7 times with 2 left over. So that's, yeah, okay. So 27.5 would be our answer there. Right? 30 times 1 oh wait, no, that's the whole thing. So 30 times 1 1/4. Okay. 7.5. 4 goes into 30 7.5 times. So then that's already 30. So it would be, the whole length would be 37.5. So I have to take 37.5 and subtract 10, which is 27.5. And then I have to subtract 15, which is equal to 12.5. So this little section right here is only 12.5. And what's my strategy? Well, I use the relationship between lines or sides of the triangle to figure out the new sides of the triangle. And then I had to subtract my known lengths, which would be right here, to figure out my little segments that I needed. Don't mind that my computer's almost dead. Okay. The synthesis. What are some strategies for determining unknown side lengths in similar triangles? You can use scale factor to determine the unknown side lengths of similar triangles, or you can use proportional ratios to determine the unknown side lengths. To use scale factor, you're taking 15 over B is equal to 5 over A, right? That's scale factor. Something times 15 is B, something times 5 is A. To use proportional ratios, it would be 15 over 5 is equal to B over A. Because I'm basically saying that this length to this length is going to be the same as, not length, the relationship between 15 and 5, which is 3, is going to be the same divided by 3 or times 1/3. It's going to be the same as this to this. I would multiply this by 1/3 to get this, or I would divide by 3 to get this, if I had those lengths. Obviously, I can't find out how big this is or what the measurements are because I don't have any starter measurement, but I know that the relationship between these two, which is times 1/3 or divide by 3, would be the same as this. I would either multiply B by 1/3 or I would divide B by 3. Either way, I would get the measurement of A, and it would be the same relationship between these, and that's what I would say there. And then for this one, show what you know. Use triangles ABC and DEF, I read that wrong. Triangles ABC and DEF are similar. Determine the missing values and explain your thinking. Well, I'm going to take a look right here. I see the relationship between 5 and 10 is 5 is half of 10. So 4 is half of 8, and that's how I would find that one right there. And then I know that the relationship between 4 and 6 is 1.5 because 4 times 1 is 4, 4 times 0.5 is 2, 4 plus 2 is 6. So I would multiply 5 by 1.5 and I would get 7.5, and then that would be my answer. So I know the proportional ratio for the blue triangle is 8 to 4. Oh, I'm going to put x because we didn't know that. X to 4 is equal to 10 divided by 5. And I know the scale for those would be 2. So I can multiply 4 by 2 to get 8. To find the third side on the green triangle, I can compare the ratio of 4 to 6, which is going to be equal to 5 to x. I know that the scale for 4 to 6 is 1.5, so I can multiply 4 by 1.5 to get 1.5. 5 to get 6. I can do the same on the green triangle. So 5 times 1.5 equals 7.5. And that is how I would answer all of those questions. If you have any more questions on this lesson or any other things that you're not understanding, please let me know. We are taking our unit test on Friday. So study up, be prepared for that. We're going to answer some questions along that we have during the week. We have 2 more lessons tomorrow and Wednesday on slope to kind of introduce slope to us, and then we'll take that test. So yeah, let me know if you need any more support.